think we can invite Dr. Noor to start her presentation. And if Dr. Abdul can join at the end of the session to conclude his work and answer any questions, would be great. So Dr. Noor, can you please join us?
Okay, thank you.
Thank you. You can start sharing your screen, please.
Okay, can you see the screen?
Yes, please go to full screen mode, so presentation mode. Perfect. Perfect.
Okay. Assalamualaikum and good day. My name is Leha Rahman from Universiti Teknologi Malaysia, and I would like to present my research on impact response of coconut fiberboards with different flower as natural binders. Okay, this is the outline of this presentation. First, introduction. Second, objective. Third, procedures. Fourth, result. And the last one is conclusion. Boards are flat pieces of materials used for special purpose. There are three types of fiberboards, which is low density fiberboard, medium density fiberboard, and high density fiberboard. And medium fiberboard is the most known fiberboard used in construction or automotive industries. Fiberboards are mostly made from natural wood. There are some limitations such as expensive, difficult to process in various shapes, and also depletion of wood because it takes a long time to grow. Therefore, there are alternative materials such as coconut fiber, coconut, and others to reduce the consumption of wood in making fiberboards. Coconut is a member of palm family. There are different parts of coconuts, which are coconut husk, coconut skin, coconut shell, and copra or coconut. Coconut coir are obtained from coconut husk that have high lignin content, which is about 30%, which it makes harder, tougher, and stiffer fiberboard. This is some application of fiberboard, which is first furniture and cabinet, because fiberboards have good physical properties, and second, construction panels such as ceiling and roof sheeting, and also in industrial wall insulation, and also housing wall insulation. In production of fiberboard, formaldehyde-based resin are widely used as adhesive or binder, such as urea formaldehyde and phenol formaldehyde. There are several advantages of using formaldehyde as an adhesive, such as excellent adhesion properties, water resistant, easy of handling, short press time, and also cost effectiveness. However, formaldehyde-based resin are considered a dangerous toxic chemical because if we expose in a long period, it may cause health problems such as cancer, leukemia, nervous system irritation, and others. Therefore, using natural binders is an alternative way to replace the use of formaldehyde resin in fabrication of fiberboard. In this study, there are three types of natural source as a binder, which is corn starch, tapioca starch, and rice flour. These three types of binder are chosen because it easily found in store and also cheap. Table shows the nutrition information on each binder per 100 gram serving size. Rice flour, you can see here, rice flour has lowest carbohydrate content, and the highest carbohydrate content is belong to cornstarch. So the objective of this research, first, to fabricate the coconut fiberboard using 3 different natural binder, which is cornstarch, tapioca starch, and rice flour. And the second is to investigate the effect of impact properties of the fiberboard at 3 different impact energy. So this is the procedure how to fabricate the coconut fiberboard. First, coconut fiber was crushed using crusher to get length of less than 5 mm. And then the crushed fiber dry in oven for about 1 hour to remove the moisture content. Natural binder, which is cornstarch, tapioca starch, and also rice flour, was diluted with water and then mixed with fiber with weight ratio of 70-30. The mixture was then placed in mold plate and pressed at temperature about 200 degrees for 1 hour. So the impact properties were measured under 3 different impact energy, which is 5, 10, and 15 joule. So the impact properties such as load carrying capabilities, energy absorbed, deflection, damage, and impact strength of specimen were measured. 5 specimen for each different binder coconut were tested, and damage mechanism of impact specimen observed under digital camera. This is the result. Table shows the impact properties of peak load, deflection at peak load, total energy absorbed, and energy to maximum load for coconut fiberboard, tapioca starch, and also for coconut fiberboard rice flour. We can see that increase the energy level from 5 to 15 joule will increase the energy absorbed, and for all coconut fiberboards. And the coconut fiberboard cornstarch shows a good performance compared to tapioca starch and also compared to rice flour. At higher impact energy for cornstarch, coconut fiberboard cornstarch, which is at 50 joule impact energy, cornstarch obtain highest energy absorbed, which is 1.5 joule. And while the rice flour obtain lowest energy, which is only 0.66 joule. Graph show the impact strength for all types of coconut fiberboards. This is for coconut, for cornstarch, tapioca starch, and rice flour. We can see that the impact strength increase with increase the impact energy. Coconut fiberboard cornstarch produce higher impact strength, while coconut fiberboard rice flour produce lowest impact strength. This is due to the highest carbohydrate content in cornstarch, where many hydroxyl group in cornstarch highest carbohydrate content, that means highest hydroxyl group in cornstarch. So hydroxyl group can wet the polar surface of cellulose, penetrate the crevice and pores to form a strong bond. The impact strength of rice flour did not give big changes from 5 to 15 joule of impact energy. This is due to poor adhesion bonding between coconut fiber and rice flour. Table shows the surface damage of fiberboard front view and back view for corn starch, tapioca starch, and rice flour. We can see that all fiberboard show the impact damage hole and crack. The primary damage are indentation induced in the surface, which indenter penetrate into the specimen. From the back view, we can see that the damaged area of rice flour is largest compared to corn starch and tapioca starch. This is because rice flour had lowest energy absorb and impact strength. And as a conclusion, the coconut fiberboard corn starch exhibit the highest peak load, energy absorb, and impact strength, followed by coconut fiberboard, tapioca starch, and rice flour. The coconut fiberboard rice flour show a large damage area compared to other coconut fiberboard due to poor adhesion bonding. And the third, the carbohydrate content within the natural blender is the main reason to influence the adhesion bonding of coconut fiberboards. The impact properties of peak load, energy absorb, and impact strength will increase the impact energy level for all types of coconut fiberboards. That's all for my presentation. Thank you.
Thank you so much, Dr. Noor, for this quite interesting presentation. So we have 3 more minutes for questions. So I invite you, if you have any questions, please to type them in the chat or raise your hand. Okay, but let me first ask a question or read a question in the chat. So the first question from Dr. Maria Raji. She was asking, we know that the starch biopolymer is soluble in water. Have you studied the hygroscopic stability of your composite, means the water absorption of your composite?
Actually, this is just the preliminary result. And we plan to do more testing, such as SAM, water absorption, thermal conductivity, density, and others. But maybe after MCO and we can access the lab, because now we cannot access the lab, so we just stick to the our result.
Perfect. So we have another question from Dr. Ashraf Al-Far. Dr. Ashraf.
Yeah, Assalamu alaikum. Hi, everyone. Really, I'm very happy and fascinated to hear all of this kind of application about fiber. Fiber is going to extend to all field of our life. But this is really would depend on the cost of development, the incorporation, the marketing, and the people who is really accept the idea to invest in production of such fibers in different field of life. My question to Dr. here, and thank you for her nice and great presentation. Have you tried the coconut fiber in ceiling or just on wall? Is it usable in wall only, or just also it could be incorporated with cement to use?
He's saying, could it be used in cement? Cement.
Sorry, can you repeat? Because
could it be used in cement?
Cement, like Portland cement, in cementation. You got my point? Hello?
Yes, I cannot hear because my internet is unstable here. Break.
Yeah, I know, connection problems. Yeah.
Yes. So Dr.
Maybe you can type.
Dr. Ashraf was asking, did you evaluate the possibility of using those like coconut fiber as filler for cement for building and construction?
Okay. Sorry, Prof. I
No
only
problem.
hear why coconut fiber, and the rest I cannot hear.
Okay, that is fine. So let's try to get the second question from Dr. Qais.
Thank you, Dr. Noor, for this presentation. I have just a suggestion. I think that's the comparison between the different bander must be correlated to understand what the banding. I suggest to use the Fourier transform infrared. It will allow you to check if there is some new banding between the bander and the fiber. It will be better in the future. Thank you, and congratulations for the quality of presentation or quality of work. Thank you.
Okay, so regarding the question of Dr. Ashraf, so we're having the next two presentations from Nigeria. Dr. Anthony Adeniji, he is discussing or presenting his work using coconut husk fiber in cement admixtures. So, so it will be presented in the next two presentations. So thank you so much, Dr.